Hello, this is Nitin Dahad with EE Times, and I'm speaking to one of our keynote speakers from the HiPEAC 2026 conference today, Deming Chen. Hello, Deming. How are you?
Hey, good. How are you?
Good. Just introduce some of the affiliations you've got right now. I think it's mostly with the university right now, isn't it? But you've got so many different things going on.
That's right. So I'm a professor of the ECE department of University of Illinois Urbana-Champaign.
Yeah.
And I'm involved with several startups. And right now I'm working on in spirit IoT, right? So during the keynote, I actually talk about one of the products developed in this startup. But in the same time, I'm involved with a couple of research centers. One is AMD Center of Excellence.
Okay.
Another one is IBM Illinois Discovery Accelerator Institute, right? So in my role, right, so I do research, I work with students, I work with my industrial partners, faculty, partners to really move research forward and hope it can make impact for the industry and for the society.
You have the best of all worlds. I think you must be having a whale of a time right now with everything going on.
Thank you. And I love the challenge and I appreciate all the opportunities. And, so the key question is what are the right problems? What are the right challenges? And how we can, motivate people to work together to solve those challenges and move forward.
Yeah, and I think that is a good segue into your keynote this morning, which is you're talking about like the message I got is the mismatch between the models and the hardware, and just how you manage to bridge that gap, as it were. And so, do you just want to sort of outline some of the challenges that you think need to be addressed?
That's right. Yeah. So the fundamental issue is that AI is moving forward so quickly, right? So if you just look at the large language models, right? So every several months you have a new version, right? However, the hardware takes much longer to develop, right? In years.
Yes.
And then when the AI community developed the most modern AI model, they may not really look at the hardware constraints, right? In terms of memory bandwidth and things like that. And then, so the hardware is optimized towards today's AI. And when it's ready, AI already move forward next generation, right? So how the AI community and the hardware community can work together. So at least they would understand each other's domain language, what are the constraints, what are the bottlenecks, how they can work together so AI honors hardware constraint, hardware can be optimized towards the AI. And from this perspective, the hardware need to be more adaptive, right? So for example, from architecture level, how it can become more reconfigurable, right, in order to be tailored towards the fast-moving AI models.
And we saw that from one of your slides this morning, and I think it's quite like a good point that it was like hardware software co-design was always the end goal, and now it's AI model stroke hardware co-design, which is kind of that endpoint which you're trying to get to.
That's right. Yes. So instead of hardware is okay, I always catch up, right? So let's approach a AI hardware co-design from the beginning, right? So I talk about how we can use a co-search approach that the AI model and hardware is co-searched very effectively, right? And then at least that provide the beginning, like starting point, and people can further refine them, right?
Yeah.
And then this new mindset is quite essential. Yeah.
And I mean, yes, when you said that this morning, and you provided the detail, but what does co-search actually mean? I mean, it's not like you go to Google and there's actually more depth to that phrase, that term.
Yeah, that's an excellent question. So when I talk about it, I mainly come from neural architecture search in the AI domain.
Yes.
And then design space exploration from the hardware domain.
Yeah.
Right. However, when we are talking about AI hardware co-design, that means these two design space need to be merged, become a common design space. And then when you search this combined design space, whether it's AI or hardware, what's the best way to search it, right? In a comprehensive way, but in an efficient way, right? Yeah, so however, this method can be extended to other use cases. For example, for large language model, a lot of time it's still designed by human, right?
Yeah.
But then how the machine learning can play a role there, right?
Yeah.
And then in terms of hardware, how the effective design space search can play a role, right? So that at least delivers some good design point for people to focus on.
Now, there's always been silos in those.
Yeah.
What do you see as going to be the trigger point where people will say, okay, well, I have to do this co-design,
Right.
I have to do this co-search?
Right, yeah. So without doing this, then we cannot really deal with the huge energy consumption issue.
Right.
So the AI model is exploding, right? And even when you train a large language model, consumes so much energy, right? So how do we really tackle the energy efficiency issues, data movement efficient issues, right? So all this need to be considered together across AI and hardware in order to effectively solve this issue.
And then people like us are making those issues like more prominent now because we're talking about them. So actually,
That's right.
What's next for you? I mean, what's exciting you right now?
Yeah. So right now I'm working on how AI can help us to develop better hardware. Okay. And then I'm also thinking about how we can expand the AI hardware co-design methodology into some new domains, right? So this can be some emerging technology, even quantum plus high-performance computing integration, right? So also some other domains that's important in various applications, whether it's healthcare, whether it's security, right, whether it's education. So the application sides are very, very exciting.
And I think when I talk to investors, those are the areas they're all working in or investing in at the moment.
Wonderful.
So it sounds like you're on the right track.
Yeah, thank you. Yeah.
Well, Deming, thank you very much.
Yeah, thank you.
Thank you.
Okay.